Hey, Abhinandan, you there?
Hello, am I audible?
Yeah. Can you just share your screen?
Yes, I am sharing my screen.
Chalega, now I can able to see.
Am I audio clear? Can you please give me a feedback on that? Am I audible clearly?
Yeah, it's fine. It's completely fine. No issues with that.
Okay, okay, okay. So welcome all. Jatin sir, can I go ahead and start the presentation on this on our topic today?
Yes, please.
Yeah. Okay, so guys, hello all. My name is Abhinandan Mukherjee, and today our topic of discussion is the random forest algorithm, and we will try to understand the machine learning aspect of it, the aspect of ensemble mod methods, and this is our main agenda today. So a few things to be cleared out first. First of all, uh, good afternoon, everyone. I hope you are taking enough care, staying at home. And at Ethans, we are trying to make the full use of this quarantine period so that we can all learn together, grow together. So that is why we have organized this meeting. I hope you have a good time. Um, it's great to see such an attendance present today. It's great to see such an attendance present today for this session. We will be discussing this topic in details. For the sake of clarity for this entire presentation, all of our attendees will be on mute. So if you have any questions, you have an option of raising your hand and posting a question on the chat window. So if you have any questions, you can raise your hand. I'll try to make a pause, take a look at what you have posted, and try to answer your queries. Having said that, it would be really great if we can spend some time dedicated for question and answers, but please do not restrict yourself to wait for the designated question and answer uh, uh, period. If you have any important question, if you want any clarity on any topic, just ask me to clarify on that. I'll be happy to do that, because this will be an interactive session. We want the session to be really interactive, so there is no point of doing so we don't have any scope of doing any hands-on right now, but we will definitely be trying to answer all your queries. Okay, so having said that, I'll try to move forward from here. So if you have any questions to be answered at this point of time, it would be really great if you can post anything. Then I'll start on with our discussion today. Okay, I see a few guys joining right now. So again, I'll be making myself clear on one thing, guys. All of you are will be on mute. So please post your queries if you have any at any point of time. Try to post them by raising your hand through the dashboard and post them through the chat window. Okay, and I will keep some designated time for question and answers. So if you can accumulate all the queries and let us discuss, have some discussions, because there will be some redundant questions obviously. So if we can have the discussions in the Q&A period, then that would be really great. But nevertheless, you can still, if you have smaller queries, you can still go ahead and ask. Okay. Okay, so good afternoon all. So again, to be very frank, we are trying to have a good understanding of what is an ensemble methodology. through the implementation of an algorithm called random forest. So we will try to understand what is its base, what does it achieve, how we can work with that. So we have prepared, so we have a deck for random forest right now, so that we will be sharing. This environment that you are seeing here is known as a Jupyter notebook environment. So this is a notebook which uses programming kernel at the background to execute certain codes that you might have in a particular programming language. So as you can see, my programming language that I am using for this particular thing is Python. Okay, Python 3. So the Python version that I'll be using here is Python 3.7. So based on the Anaconda that you are using, it will be fair to you. Okay, so what are we trying to do here? We are trying to see a machine learning problem, particular machine learning problem called classification. Okay, so what do we mean by classification here? So see, machine learning can be classified under multiple categories like supervised, unsupervised, reinforcement learning. So we are currently today our focus is on supervised learning. So in supervised learning patterns, what we have is a pair of dependent and independent data. Okay, so you can consider them like a function. Okay, so let's say when we talk about a linear equation, you have a function like y equal to mx plus c, where y is your dependent variable, dependent value, which is dependent on the value x, which is independent. Okay, and m and c are typically coefficients and intercepts, which are constant values, right? So supervised learning is a similar idea, okay, where we are trying to recognize patterns, where we are trying to recognize patterns by going through the concepts of paired values. Okay, so we have a certain causative relationship. That means based on some values of x, there is a relationship which predicts some, or there is a relationship which tells us certain y values. Okay, so when we have certain causative relationship like that, we can perform machine learning to recognize the patterns, such patterns, and by that we can create a relationship to identify or predict certain y values based on some given x values. Okay, so that is the idea. So how do we do that? So in order to do that, the basic principle is that we will have a pair of known x and y relationships. We will have some x and we have some y relationships based on that. And when we have some known values, we will try to understand the patterns on of those known paired relationships, so that we will be able to make certain predictions on certain unknown x values. Okay, so let's say if you have, just to give you an example, let's say if you have experience, we have a data where we have experience and salary, and we have a causative relationship that based on certain experience people get certain amount of salary. Okay, now you have, let's say, some data having 1 year, 2 year, 3 year, 4 year, 5 year, 6 year experience and certain salaries. Okay, but you don't have a value, let's say, called let's say 2.3 years of experience. You don't have the salary corresponding to that. So you create a model, you create a relationship based on what can be extracted from the given values, and then we use the model to make those calculative prediction, so that what will be 2.3. Okay, based on 2.3 years of experience, what should be the salary based on what data we have. This is a simple example of what we try to achieve through this kind of a supervised mechanism. Okay, so when I say classification is a specific supervised mechanism where we are trying to have prediction, or let's say pattern recognition or machine learning being done for a specific kind of y, which is categorical in nature. Okay, so when I say categorical, it has specific categories, like let's say yes, no, red, blue, green, and let's say 0 1 true false, let's say Sunday and Saturday, specific categories. Okay, it cannot be any random value, it has to be specific categories. Okay, so when we have a variable or a value of y which is depicting only specific categories, we are restricting ourselves to a specific machine learning problem which is called as classification. Okay, so that is what we will try to see here. We have taken an example of classification, and that is what we will be trying to look at here. Okay, so in order to do that, we are going to use a simple example from say an example data. We will extract a data set from very famous data set from scikit-learn. It is a data set contributed by UCI machine learning repository. You can note that down, UCI machine learning repository, and you can go to that specific website. This particular website gives you a categorized, well categorized and organized data set repository based on all the data sets that have been used for different machine learning based research purposes for more than 20 years. Okay, so you have a great data set repository there that you can look into, you can use, you can get data based on different categories. Like you want to have classification or you want to do regression, you can just select regression or classification or something else as a task, and you will see multiple data sets and lots of things that you will be able to classify and look into. Okay, so that is where this data set is sourced from. But we are going to use Python based libraries, standard libraries for these operations. So we are going to use scikit-learn for this purpose, and scikit-learn API provides us with a dataset loading utility that has a certain datasets already loaded into that. So just to show you that example, or let's say, if I say, if you just Google scikit-learn API, this will be your landing page, and this provides you all the API, all the necessary information on scikit-learn. So I'll just take you to scikit-learn datasets, and here you will see that the datasets have been classified as per their task. So this is a dataset for classification, this is a dataset for regression, and so on. So I've taken this famous dataset on breast cancer. So this is a Wisconsin breast cancer dataset that is being used for classification. What this dataset gives us is information on different on different tumor related information. Okay, what was the mean radius, what was the mean texture, parameter, and all these information on different tumors, and based on that it gives us a value at the end which says either 0 or 1. If the value is 0, that means that that the particular tumor is basically benign, that means it is not cancerous, or if it is malignant, it means that it is basically cancerous. Okay, so that is the idea behind this particular data set. So we can use this scikit-learn utility to load this dataset, or you can go to a machine learning repository in UCI, and from there also you can download and load the dataset. When you use the scikit-learn API to load any dataset, you will see that the scikit-learn API gives you a very simple utility. Okay, so it gives you a simple function. Okay, so if you call this function, it will return a data set type, like an object which looks like a dictionary kind of a thing, dictionary like object. It will return that thing, and we can extract different information from there. So if you see that the return is a bunch which is a dictionary like object. Okay, so in this dictionary like bunch, you will get things like data, target, and different other objects. So I'll show you. So if you just look into this, what I'm doing here is that, let me quickly run this. So I'm loading breast cancer, load breast cancer. I'm calling this function. I'll get the data, and that will be this breast cancer data is my basically my dictionary like object which has all the data. Okay, so it is taking a few minutes. Okay, let it load by that time. Yeah. So if you just look into this, we'll see that we have keys like data. This is when you press data, this is simply all the information in an array like structure, all the basic data in an array like structure. Okay, if you do description, you have to keep this in print, and all of the information about this data set will be given in this description. You can see what this in each and individual columns mean, and all the information about this data set will be provided here. Okay, you will see that it has been sourced from UCI, and this is the link for that particular thing. Okay, so like this, you will have lot many information already present in this scikit-learn utility. Okay, so that is why we are using this specific utility here. So what I'm doing is from here, I'm creating a data frame for my use. So in order to do that, I'm using all my data. Uh, the column names are also provided in a particular key called feature names. Okay, so all of the data and its column names, I'm concatenating with the target values, and I'm concatenating this column wise. So this is a simple pandas operation. I hope all of you guys are aware with this operation. And as soon as I create this data frame, you'll see that the entire data is very clean, well structured, and in numeric format, and this is how you can see the data. Okay, just simply put together, if you just want to see what is the structure of the data, then you can just, as you all are well aware of this, you can just do a data dot shape, and you see that we have, this is a very simple data. So we have around 570 rows along 31 columns. Out of that, 30 columns are my independent, and I have one target feature, that is this last feature, has cancer or not. Just give me a second. Hello. Yeah, excuse me for that. Yeah. So I've just used data describe here. So because all of the data I have is in numeric, we can just straightforward do a use a describe method, and it will give me univariate statistics on all of my variables here. Uh, so we could get some important information. We could extract some information from these univariate statistics from here, but we are not going into the inferential part here because our focus is not on that right now. We are trying to understand how typically an ensemble method through random forest could be implemented. So I'm not going into any kind of feature engineering. I'm not going into any kind of, let's say, data pre-processing. I'm not doing any such things like that. That is why I've selected this data set where it is not really needed that much. Although you can go ahead and do that, but yeah, I'm not going to do that. I'm going to simply use this data and go forward with what is the modeling concept behind this. Okay, so very simply, I'm trying to split my data into train and test split. So in order to split my data into train and test split, what do we have to do is we have to provide our independent part and we have to provide our dependent part. We could have done this in other ways as well. So this is my preferred way. So that is why I'm selecting this. I will also use a random state parameter here. And for that, I've used a, a random seed that uh, I've already, as you can see, I've already used a random seed at the top. This random seed helps me keep a tab on the seed value so that I could regenerate or you can say reproduce the same random state results over and over again. Okay. So with this, what I'm going to do is I'm going to split my data into train and test. So my independent part has been splitted into xtrain and xtest, and my dependent part has been splitted into ytrain and ytest. Xtrains corresponding y is in ytrain, and xtests corresponding y is in ytest. So these are the pairs. Xtrain and ytrain is a pair. Xtest and ytest is a pair, which has been handled by this method train and test split. Okay. So in order to understand this random forest mechanism, the first step that we have to understand is our decision tree, because decision tree is the basic idea behind any ensemble or behind any forest-like mechanism. Okay. So what is a decision tree? A decision tree is a very simple concept. Okay. Okay. And in this concept, what is basically done is a decision tree through a mechanism of information gain. It tries to um, classify in, because we are using classifier, so it will try to classify our data. Okay, it is a non-linear method. Okay, there are classifiers that we can use which are linear in nature, but decision tree is a non-linear method. Okay, why? We will have this discussion in a few minutes, but please understand this, that we are not diving deep into the entire concept of decision tree here, but I'll try to make as much illustrated info. I'll keep as much illustrated description on decision tree as possible. Okay, so I'll try to approach this in a different way. Okay, so if you have any questions on these concepts, so let me know. So I'll stop here. Till here, do we have any doubts right now? Yes, please go ahead and ask. I could see a few people have raised hands, so if you can ask your question. Okay, Mayank asks what is this X-train, X-test, and Y-train and Y-test? How are they related? Okay. So this is a very simple concept, Mayank. I think I'll have to be. I think a few people are unaware with these concepts. Then, okay. So let me quickly just give you an overview of this understanding. What is the thing that we are trying to achieve through machine learning or modeling here is that um, we we are trying to create a generalized model or a generalized idea so that it could and we are trying to create that by uh, teaching a type of data so that it can understand that, and then asking it to make predictions on something that it hasn't seen before. How can you understand what I'm saying is, just simply think that how have you learned throughout your educational curriculum? You have been given a book, there were questions and answers, you have studied those questions and answers, and then you have been asked to take an exam. You go to the exam, a few questions were given for you to answer, and then you write those, you come back, some person checks that, and you're given a result, a report card. By looking at that, you understand that whether you have learned what you have learned actually is good or not. Okay, somebody corrects that and tells you, okay, what you have written is not good, or what you have written is good enough, and works like that. That is the entire idea. Okay, now where is this different? Because see, sometimes in our educational curriculum, a lot of time what happens is that whatever you have learned. Hello, am I audible? Shashank says that, yeah, okay. Okay, now, so whatever the okay, what I was, yes, so in our educational curriculum in India, so a lot of times what happens is that we learn something from the book, we go to the exam, and the same questions are given. Whatever we have mugged up, we just write them down, and we are getting good marks, and we are happy. Everyone is happy. Your parents are distributing sweets. Okay, very good, win-win situation for all of us. But the problem is that when you really face a competitive exam where millions of students are participating, you sometimes don't do good because the questions are not that easy there. Like let's say in JEE, or let's say in AIEEE, it doesn't work like that because the questions do not come from the book, right? So there you have to apply your brain, apply yourself, and answer something that you might not have learned directly, but you have to construct something out of what you have learned, right? That is the general idea of whether you know something or not. Okay, whether you have understood something or not. That is how people are getting treated. So we want to train models in the similar principle. Okay, so let's say I give a certain data x and y, where I say that based on x, y can be understood. The example that I used was that based on experience, I could say someone's salary should be in what range. Okay, so if I use let's say the data, let's say some data to train my model, train an algorithm, and say that okay, based on this data, a person with 1 year experience will have a salary of 20k, a person with 2 years experience will have a salary of 25k, a person with 3 years experience will have a salary of 30k, and so on. Okay, so that is my data. So based on this data, if the model is trained properly, I ask the model, okay, model, what will be the salary of a person with 1 year of experience? Model will definitely say 20k, and that's good. Now this is what we usually do. That is the example. Like in India, what we do in exams, we have been we have trained on something. We have been asked the same question. We give the right answer. Everyone is good, right? But then what happens when I ask the model the question, okay, what will be the salary for a person with uh, Monisha says God. I'm not sure. You have to be more precise with your question. So let's say when I ask the model, okay, model, what will be the salary of a person with 2.5 years of experience? Now the model has a understanding that 2 years of experience was 25k, 3 years of experience was 30k. So 2.5 should be somewhere between 25 to 30k, and the model should be able to give me an answer like 26k or 26.5k or 27k. We accept all of that. but that should be the range. That should be that should be the predictable range, because that is what mathematically defines the relationship, right? So our model, although it was not trained on the data that was 2.5 years of experience with certain salary, the model is still able to make that prediction. Okay, without knowing that, still able to make that prediction. That is what we should be able to achieve through this machine learning process. Okay, so the idea is that we will have to train a model through we have to get a model, we have to train an algorithm based on certain data, and then test it or evaluate out based on certain unseen data, and then we will be able to figure out whether the model has learned properly or not. Okay, so that is the idea. Umesh says, I think the question was, out of 569 rows, will there be 75% of training and um, I think that was not the question, Umesh. The question what Mayank asked, yes, okay. So no, that was not the question. The question what Mayank asked was, he was not sure about what X-train, X-test, Y-train, Y-test are and how they are related. So just to make sure that we are on the same page, because I'm not sure about your background, so what you know currently. So that is why I'm just making sure that we are on the same page and we can move forward easily. That is what my take is on this one. And to be Umesh, your split percentage, I'll be discussing that. Okay. Okay, so so that is what our objective is. In order to achieve that, we are given one data set, that is my breast cancer data set. What we do using this train and split function is that we split that data into two divisions, a train division and a test division. Okay, in the train division we have X train and Y train, and in the test division we have X test and Y test. Now what do we mean by that? We want to train our model with the notion that based on these X train, these Y train have been noted. Okay, this is what we give the model to learn on. Okay, this is the book that you have been provided at the start of the semester, like that. Okay, and X test and Y test is the question paper that you have been given on the day of the exam to have an answer, give an answer for. Okay, not the Y test, the X test part. Okay, so what we do is we train the model on X train and Y train. Okay, then we give the X test to the model so that the model can make some predictions. We evaluate those predictions with the Y test and to understand whether our model has done good or not. So as we move forward, this will be more clear. Okay, clearer in that sense, but this is the general idea, okay, of what we are trying to do here. Now we can define the percentage of the split. So let's say I am defining here my my test size as 0.25. I see an insert, just a second. Okay, so I am defining that I have a test size of 0.25. That means that I will define this entire data set into a 75 and 25 split, where my train will have a 75% of the data and test will have 25% of the data. Okay, I have a question. Monisha says, Oh yeah, okay, that's okay, Manisha, not a problem, not a problem. I understood that. Yeah, not a problem. Okay, so this is how I am trying to split my data. So if you just see that my total data set at 569 rows, and if you see now xtrain will have 75% of these, and xtest will have 25% of the 569 rows. Okay, xtrains corresponding has cancer column, these whether it was 0 or 1, whether the person had cancer or whether the tumor was cancerous or not, is present in this value y train. Okay, because if you see y train here, you will find that it has 1010 like that, and so on, y train and y test. Okay, so this is the idea behind xtrain and these splits, where what we are trying to achieve is simply we are trying to split our data into train and test splits. We will use the train part, that is the 75% of the entire data, to train our model, and then we will evaluate them on the test set to understand whether our model is performing okay or not. Okay, so this is the idea. Now the first thing that we will try to do is a decision tree. Okay, so what does a decision tree do? I'll explain that to you in a few minutes. Okay, somebody, another question I have. Rituja asks, can we check xtrain at this point? Okay, yeah, you can definitely do that. Do you want to, by that, do you want to say that, do you want to see xtrain? If that is your question, then this is what you have in xtrain. These are the set of values that you have in xtrain. By values, I mean that you'll be having, okay, I have one thing to do. Okay, so this is what you have in xtrain. You see that in xtrain, we have selected a few rows. You see ytrain has the same rows. The only difference is in xtrain, you are having the independent columns, and in y train you have the dependent column, which is suggesting whether that tumor was cancerous or not. That means this tumor, the 464 row, this tumor which has mean radius of 13.17, mean texture of this, was cancerous, and this particular in 337, this one was not cancerous. This is what it means. Okay, this is how the data is split. Umesh says, Abhi, does it take randomly 75% rows or in ascending manner from row? No. First of all, nothing in ascending. So index wise, it is not ascending or descending. It is shuffling and then taking some data out. Okay. So nothing related. So nothing is being ordered in any way. Okay. Now, does it take a like if you are not specifying if it what percentage it is taking a 75-25 split. Okay, moving forward. So what does a decision tree do? So this is a very simple question, but let us see that in details. I'll show that to you in a different in a pictorial format. Okay. So what I'm doing is from scikit-learn's tree package, I'm importing this class called decision tree. I am creating an object of this class with the maximum depth of 5. What is maximum depth? You'll be able to see. Just give me 5 minutes on this one. And then what I'm doing is I'm training the model. In order to train the model, scikit-learn gives us a method called fit. We have to pass our xtrain and ytrain that we have created, and it will fit or train this decision tree model. Okay. So this model, this decision tree algorithm is right now, I've named this as model. Okay. I could have named that anything. I have named this as model. With different Python packages like GraphViz and Py.plus, we can actually get this decision tree in a visual format. Okay. So this code I see. This particular code is simple code. It has no tricks. You can Google this stuff out. This is very simple to understand how to visualize a decision tree. But the thing that is not visually representable is how this particular data or this decision tree is represented in this format. So this is what I'll be explaining right now. Okay. Yes, you can ask a question. I see Mayur has a question. Mayur, you can go ahead and ask. Okay. So what the what does this show us? So what happens in a decision tree is a decision tree takes the data, okay, and then it tries to order the data. You can say. What do I mean by ordering the data? I'll give you a very simple thought experiment. Okay, let's say if you have, I give you a packet of Cadbury gems. Okay, you know that there are multiple, that those gems Cadbury's have multiple colors like yellow, green, blue, all of those stuffs, right? So when you just open that packet, you tear that packet out. At that point of time, if you put your hand inside, you don't know what color will come out. Okay, you have no idea of that. But let's say you one by one take out all the yellow ones first out and order them out. Okay, at this point what happens is inside the packet you still have a lot of mixture, okay, a lot of heterogeneous composition, but at least you have one ordered set out. Okay, so what I'm trying to say here is you have decreased the heterogeneity here. You have decreased the level of mixture that was earlier present by segregating one group out of that. Okay. If after you have segregated yellow, if you have taken another step and segregated all the blue ones out, you have decreased the heterogeneity a further step down. If you go on doing this and you segregate all the groups out, and you have taken out all the gems from from the packet, what happens is you are left with only homogeneous groups, homogeneous clusters. You don't have any mixture left. You don't have any heterogeneous composition left. Okay, this particular idea is very important to understand decision tree. See, the measure through which this heterogeneity is understood, okay, is called as Gini impurity. Okay, Gini. I'll discuss it again. Gini impurity. Okay, it gives us an idea of how impure the data is. The more impure the data is, we have more need of segregating the groups out. Okay, the more you segregate the groups out, the better your Gini impurity improves. Okay, so what the decision tree does is it tries to segregate the data in terms of your target value. So here my target or y is the dependent value is has cancer, which can be 0 or 1. So based on all of the data that you had, okay, based on all of the data that you had, we will try to group the data into two groups mainly. Whether somebody can be classified, whether some particular tumor can be classified as a cancerous tumor or not. Okay, that is the basic concept. So in order to do that, we calculate something called Gini impurity. Okay, Gini impurity, and we make binary trees like this. Okay, simple binary trees. So what happens here is at every, these are called nodes. Okay, a node which is capable of branching more can be a root node. Okay, a node which cannot branch more are called leaf nodes. The information that are provided here, I'll discuss one by one. This is the column name, worst perimeter. This is a value. Okay, so worst perimeter has values. So what we are saying is, if the worst perimeter is less than equal to this, if that is true, then we will move to the left side of this. If that concept is false, we will move to the right side of it. Okay, when we consider this particular column and this particular condition, then we have a Gini of 0.471 at this point. Okay, this particular Gini has been selected out of all the other columnar, all the other columns Guineas, because this is the least one. Okay, and at this point we had 426 rows, samples 426. Okay, so if you see why 426, because in my train data I had 426 rows. So I am providing all of my data here. Okay, when I branch from this mechanism, I see that worst perimeter less than equal to 105 15 point something. These values are 293 in number, and these values are 133 in number. And very easily we have segregated based on these particular values. And so on, these branching will go on, and we will go down to some leaf nodes. Now, why are we doing this? Because you see that when we are doing these kind of branching, you see that there is a color difference, right? We have some different colors. Okay, so the blue colored nodes define benign. That means has cancer is 0, and this orange ones define malignant. That means has cancer is 1. That means these are malignant ones. When you see some values that are present here, we will be able to understand that these branching are very easily classifying something as these malignant or benign. This particular node has 23 samples, and all of the 23 are malignant. That means if I check that, okay, this tumor's worst perimeter is how much? Okay, it is less than equal to 115. So I come here. What is this tumor's worst concave points? It is less than equal to 0.132. Okay, then that is also it is not less than 0.132. Okay, then I'll check this one. Okay, what is the worst texture? Okay, it is not again less than 25. I'll check this one. What is the worst concavity? Okay, this is again not less than 0.224. Then I'll come here. That means this features define that this particular tumor will be malignant. Okay, this is a decision making process. Through these conditions that we are defining, the decision branching is being facilitated. Okay, and these conditions are being calculated based on Gini impurity, which I'll be discussing in a few minutes. Okay, just give me a second. A decision tree has, if you see that it has levels. Okay, so this is the 0th level. We don't consider this because all of my samples are being considered here. After this, if you see, you have 1, 2, 3, 4, and 5 levels. Okay, this is defined by max depth. This is defined by depth. If you remember that when I created the model, I had specified that my depth will be 5. Okay, that is why I have 5 levels here. If I would have specified my depth will be 2, then it would have stopped here. My depth will be 3, it would have stopped here. Okay, if I would have specified that no depth, I would have not used the depth, then the decision tree goes on doing this branching. It does not stop. Okay, it keeps on doing branching until it ends up with one value only at the leaf, and it is unnecessarily excess branching. It makes excess branching. Now that creates some problem. That is what we are going to discuss. So first of all, what is impurity gain? Okay, so impurity gain is very simple. Okay, it is the probability 1 minus the probability of success square minus probability of failure square. Okay, so pi defines your outcomes. Okay, your mutually exclusive outcomes. So for us these are has cancer or does not has cancer. Okay, so for each node we calculate what is 1 minus 1 minus the probability of having cancer square minus 1 minus probability of does not having cancer square. Okay, so that is how Gini impurity is used or calculated. And then we basically what we do is we basically try to do a weighted average of this Gini impurity. Now you should be familiar with these statistical terms. Okay, so a weighted average of these Gini impurities to um, get a quantity called as information gain. Okay, so I'll not be diving deep into this concept right now because this is beyond the scope of today's discussion. So information gain is what you see here. Okay, so what we do is we calculate the Gini impurity and we understand the information gain. What our motive is that if you see in this diagram, what our motive is that we want to decrease the collective Gini impurity as we go down. Okay, and as we decrease the impurity, we actually gain information. Our information gain increases as we go down the decision tree by doing this. So the maximum decrease that you can get by from Gini is 0, and the maximum information that you can gain is basically like at max that you can go, but that is a different problem altogether. Okay. Okay, so as you can see, eventually the total Gini impurity to the last level goes to 0, meaning each node is completely pure. Okay, everything is pure in the last node. That means it is suggesting that there is no chance that a point randomly selected from that node would be misclassified. That means this particular thing, if you see here, this particular node has certain misclassification. What is its misclassification? It is saying that this particular node has 11 samples. Okay, out of these 11 samples we have 2 malignant and 9 benign. Okay, but this node as a whole is suggesting that it is benign. Why? Because the number of benigns are more in this node. Okay, so we have 2 misclassified points. If you don't restrict your decision tree at any depth, it will keep on going till your Gini impurity becomes 0. And at that point, at such a point, you will not have any misclassified points, any misclassified samples. That is what is being suggested by the definition of decision tree. That is how decision trees try to learn. Now, why that may be good, may sound good, but that is not a good thing actually. It will give us a very big problem of overfitting. Okay, why do we call this overfitting? Because it is only the decision tree will only be able to do that properly without misclassifying, will only be able to do that properly on the training data itself. Okay, okay, I have a question here. Raj Singh asks, so we can say that as we go down the tree, Gini impurity comes down to 0 is nothing but the normalizing the data for better decision. No, it is not normalizing the data. Okay, it is the nature of decision tree. See, the idea is it does not understand whether to when to stop. Okay, it has, you understand the loop, right? If you have a loop, there should be an exit condition for the loop. Okay, decision tree do not have, if you let it just run without specifying any depth or anything, then it will try to learn until the Gini impurity becomes zero. That is the exit condition for the decision trees learning process. Okay, so until that Gini impurity becomes zero, it will continue learning, continue branching, continue branching, continue branching. It will go down until Gini impurity becomes zero. And when Gini impurity becomes zero, absolutely zero, at that point it is very possible that the tree has overfitted. That means all the leaf nodes are suggesting one individual row itself. Okay, everything will be one individual row itself. I think that answers your question, Raj. It is not it is not normalizing the rhythm. Okay, now why are we talking about overfitting and why is that a problem? So we have to understand this. We have already discussed this. The objective of machine learning model is to generalize well to the new data that it has never seen before. This is a very important concept. You have to understand this. Overfitting occurs when we have a very flexible model. What is by flexible, what we mean that whatever we have given in the training data, it has tried to learn everything that it could see, everything. Okay, high capacity, which essentially memorizes the training data by fitting it closely. The problem is that the model learns not only the actual relationships in the training data, but also the noise that it represents. Now, this is a very important concept. Let me clarify this properly, then you will be able to understand. What has happened is overfitting is that if I give you a book, okay, I've given you a book, I've asked you to learn it for this semester, and you have learned everything from every page, including the page numbers. You have marked up everything. Okay, now I've asked you a question from within the book itself. You have given me a perfect answer. Very good. Okay. Now, if you have learned only that and mocked up everything from that book only, what happens is that if I've asked you a question from any other book, or let's say I have just tricked you by rephrasing the question in some other patterns, you might not be able to understand that because you have memorized everything word to word from that book only. Okay, this is known as a high variance scenario. Okay, where the model tries to learn everything on the training data but does not understand anything out from the anything out of that. Okay, this is the overfitting scenario. Another scenario on the contrary side is that a model can be very inflexible. It does not want to understand most of the things. It does not want to learn most of the things. It has a very high bias, and it makes a certain assumptions of the training data. Oh, okay, I understood, but I don't want to learn everything. That happens when the model tries to underfit. It does not go through everything. I give you a book, you learn one chapter, you say that, oh, I understood the entire thing. You keep it, you don't learn properly. Okay, these are two extreme scenarios. Okay, we don't want either of them. We want a model to understand things that we have provided, but not to the extent as overfitting. Okay, we want to keep a general idea so that we understand the concepts, and then we would be able to generalize them on some new data that we haven't seen before as well. Okay, so that is a particular thing that is a problem with decision tree. If we don't know how to handle a tree, what happens is that decision trees are good learners, but then it is very prone, it tries to overfit. It is prone to overfitting by itself. This happens when we don't limit the maximum depth or other parameters. Very frequently the maximum depth. Okay, because when we limit the maximum depth, we try to limit how much the tree learns, and by that we keep a hold on the decision tree's branching mechanism. So if you go back to the image, you see that I have limited that to, you remember that I have limited the tree to a depth of 5, right? And at that point, the classifications are not properly correct. I told you that there are some classes leaf nodes which are misclassified. We have some misclassified points. But then what is happening here is we have actually reduce the variance. We have not let the tree to overfit. We have reduced the variance, but we have some biases also, because by giving the idea that the max depth is 5, we have introduced certain biases in the trees learning mechanism as well. So there is a trade-off. You might have heard, some of you might have heard about this term of bias variance trade-off while fitting a model. That is also not a part of today's discussion. It is out of scope, but I'll give you a brief understanding that this is the trade-off. Okay, so you can let a model learn too much, or you can restrict that, but then again it might not learn a lot of things. Okay, so how do we restrict that? How do we use that? Decision trees are very peculiar to handle in these scenarios. Okay, so there is a specific process of decision tree called as pruning. So what is pruning? Pruning not only limits itself to decision trees, but it is also applicable to a lot of other greedy algorithms across data structures. So if you have worked with other algorithms or searching and sorting, so you might have heard about pruning. Pruning is a very familiar technique in case of machine learning for decision trees. What we do with that is it reduces the size by removing sections of the tree that provide little power to classify. Okay, so what we mean by that is that if you see if you see a tree like this, and you see that this particular part is here it is important, but let's say this particular part is a certain part that does not give us good result, but still it is a certain part of the tree. Okay, so with pruning what we can do is we can take that part completely away from the tree structure, by the from the tree, because it is not giving me a lot of information, but it is actually helping us by reducing the size of the tree, so that we can make decisions or reach decisions faster. Okay, in Python, we can do pruning. We can facilitate pruning by a lot of techniques. Okay, a good technique is to have a randomized search of multiple parameters, which can be done by hyperparameter tuning. You can look over that particular topic. It will be a good exercise for you after this. So, but there are other methods as well. If you are using other languages, there are also options of pruning, and that is how it is done. So this is the idea of a decision tree. So what uh, a basic recap of decision tree is that decision tree is tries to learn on the data, tries to learn on the data by branching. Why it branches? Because it tries to create nodes of having homogeneous cluster of data, homogeneous with respect to the y or the target variable, target classes, and but it is very prone to overfitting because it keeps on branching and branching until it reaches the minimized format of the impurity index, that is Gini. In order to reach that level, it keeps on branching a lot, and then it becomes overfitted on the training data. So what we need to do is we need to have a mechanism so as to use this very powerful decision tree modeling structure, but not to get overfitted. Okay, and in comes your process of ensemble. So what is ensemble? Very simple idea is that we all are familiar with concepts like working in teams, right? So working, they just giving a simple example. Let's say a cricket team. In a cricket team, there will be a few all rounders. All of the players cannot be all rounders. Okay, the team's lineup is always used by, let's say, top order batsmen are always good batsmen. Then there are some batsmen which are very big hitters. Then there are some batsmen which are constantly strike rotators. Then we have some all rounders. Then we have some bowlers, and that is how a team is structured. Everyone has different, you can say, different um, tasks assigned to them. any sport, you look into any sport which involves team activities, there are different tasks. In an IT organization, there are teams with different different things. There is a DevOps team, there is a developer team, there is a front end team, there is a back end team, there are different infra teams, and all of them are working together making something work. Okay, everyone has different skill sets, everyone has different experience, they are all making things possible by working together. That is a simple idea of ensemble. If a decision tree is a good is a good model, is a good algorithm, okay, why not use multiple of them to work together? Okay, so that is the idea. But then, will that achieve with that will we able to achieve the problems of a decision tree? Let us see. So in order to do that, we will see there are two types of ensembles that we should be discussing, but we are taking one of them, that is called as bagging. There is another type called boosting. Maybe that's another topic for another day, but today we'll be discussing bagging. Okay, so what is
Yeah,
bagging?
Abhinandan.
Correct.
Yeah. Sorry to interrupt you.
Yeah.
Actually, we have planned this session for an hour, and we are all already running a short of a time. So, how much time do you think it will take more?
I think I'll require 20 minutes more.
So better if we can have this session on Monday.
I'm okay with that. I'm okay with that.
Should be fine. Huh? So what we can do is we can continue further on Monday because most of the people are doing work from home. So almost 1 hour we have spent over here. So what I suggest is I may create a new link and share with the student after this meeting. And if they want to join it, they can join on Monday. From onwards, they can proceed further.
Sure, sure, definitely works for me.
Okay.
Okay.
Okay. Shall we wrap up over here?
Yes, we can. We have a good sync point, so we can do that. Yeah.
Okay, that's wonderful then. So, guys, do you have any questions? All seems fine with you. So, can we proceed on Monday? Remaining part of it.
Yes,
Okay.
I think most of them are good. But Jatin sir, do you want this like can we have a mechanism to share this material with people?
Yeah, you can attach in a handout over here. So you can see the handout window.
Yes.
In
Okay. Yeah.
there you can able to share it. Otherwise, what you can do is I have
Mhm.
to just put this session is also recorded, so I have to put this session into YouTube. And
Mhm.
normally I share these slides with these material with the student through an email. So if you can forward it to me as well, I can forward it.
Yeah,
Otherwise,
that
you
will
can.
be better. Yeah. Yeah, that will
Okay.
be better.
So
Yeah.
I make only the second session, which we are planning on Monday, only for these people who have joined today's class, so that they understand the context of it.
Yes, yes, that will be really helpful. Yeah. Okay.
Yeah. So thank you so much, Abhinandan.
Thank you all. Yeah, thank you all. Thank you. Thank you, sir.